Hi everybody and welcome back to Keto Gaia Kitchen, now renamed Hunter Health. Today's guest is one of my health heroes. Dr. Stephen Hussey is a chiropractor and a functional medicine practitioner. He's also a health coach and a speaker. Dr. Hussey has a Doctorate of Chiropractic and a Master of Science in Human Nutrition and Functional Medicine. He's written a number of books: Heart Evolution, Understanding the Heart, and his latest one, Pain Sense, which I hope we can touch on at the end. I have my own copy of Understanding the Heart, which I can highly recommend. It is a totally new way of looking at heart health, and it really opens the door to having a much wider conversation about the role of the heart. It goes into wonderful detail to explain the real function of the heart, how blood moves through the body, and it also includes a fascinating view on the topic of how the body moves from order to disorder or health to ill health. It's thought-provoking and groundbreaking. It takes the complex and makes it easy to read and understand. And I also enjoyed the autobiographical aspects of the book, where we learn about Dr. Hussey's own experience with heart problems, which we will find out about in a few moments. So, Dr. Hussey, thank you so much for joining me today, and I'm so looking forward to chatting with you.
Yeah, thanks for having me on. I'm happy to be here.
Brilliant, brilliant, thank you. So I'd like you to start with how you found your way to work in health, because I know that when you were younger, you had some worrying health conditions, one of which has continued into adulthood. And I'm wondering if being poorly as a child is what motivated you to wanting to work in the field of health and medicine.
Yeah, it definitely pushed me in that direction. I mean, from a very young age, I had what I would call inflammatory conditions. Everything from asthma to allergies to, I used to break out in gigantic hives all over my body, some kind of allergic reaction,
Mm.
had irritable bowel syndrome, and ultimately at age 9 was diagnosed with type 1 diabetes, which is different than type 2. It's more like my cells stop making insulin rather than I'm still making it and not responding to it, which is type 2. And so, yeah, I learned over the years going to doctors to help with those conditions. That, they couldn't really tell me why they were happening. They would just try and suppress the symptoms. And B, as a type 1 diabetic, I learned that I'm heavily predisposed to heart disease. And so, it wasn't until I became an adult and went to college and started to figure out that I could get rid of a lot of these things, these symptoms or these conditions, with changing my lifestyle. And so I started doing that kind of stuff. And I'm happy to say that most all of those conditions are gone, aside from type 1 diabetes.
Mm.
Um, and so that's kind of like, collateral damage to happen because of that inflammation. Now those cells don't work.
Yeah.
So yeah, so that and that heavily predisposed me to heart disease. And so I've always been very interested in heart disease and always just kind of, looked into it from, my medical training, always paid attention when we talked about heart disease. But I've learned since that what I learned in medical training and what most doctors learned in medical training is very contrary to what the truth is about the heart and
Mm.
heart disease. And there are many reasons for that, which we can get into if you want.
Mm.
But I found it interesting that no doctor ever really told me this, that I could change my lifestyle and affect these conditions, and that what I was learning in medical training was contrary to what I found out later. And so it's just been this never ending journey for me to find the truth or find different information, different ways of explaining things, understanding why life is here, how life maintains health, and trying to optimize that. And so, yeah, I've been on that never ending journey.
Yeah, yeah. And was that started through something you read at university, or something that you were taught, something you came across, or something somebody said to you?
Yeah.
What
So I
what
think,
what what kind of started you on
yeah.
that
So I
journey, do
think
you
that
think?
originally what it was just that thought that why didn't my doctors tell me about like changing my lifestyle?
Mm.
Why it was always just managing conditions. And then it was my college girlfriend was very into like alternative therapies. And so she was pushing me in that direction as well. She was that early influence for me. I was recommended a blood pressure medication, even though my blood pressure was normal, but it was just like to quote unquote protect my kidneys.
Mm.
And she was like, don't take that. You don't need it. It's just, the only thing they know how to do is prescribe medication. And so that was kind of in my ear. And then after that, it was, diving in to everything myself. It was just reading and reading and reading and
Mm,
not really being or having any preconceived notions about what things were supposed to be like as far as function of the body or of the cardiovascular system,
mm,
and just kind of reading everything that I could. Even if it didn't make sense to me, I thought it was crazy at first. I'd always read something later that was like, oh, maybe that wasn't what I read earlier. Maybe it wasn't that crazy. It was just having that curiosity,
yeah,
which I
for
think my
sure.
dad kind of instilled in me as a
Mm.
kid, because he was always asking why. And like we'd be like, oh, that's the way it is, Dad. And like, because it's this. And he's like, yeah, but why? It's making us think, um, which I appreciate. So it's just got that kind of stuff. And then, you know, in my own health journey, it was always just like curiosity from my perspective, like how do I fix it? Why are these things happening? How do I fix them? That kind of stuff. And it's harder than people think, within our modern world. There's a lot of work that has to be done. And that's just how it is. If we want to live in this modern way of life, how do we live in that life and still mitigate
Absolutely.
the
I
the
think,
risk of those things? And that's where the work comes in.
yeah, this is the problem, isn't it? This is what I always say to people. The problem is living in the modern world, but navigating through it, given the fact that our cells almost want to function in a completely different way. So it's trying to find that sort of balance. And I guess everyone's, maybe a little bit different as well, really, with things that they can tolerate and things that they can't. So that's really fascinating, about how you first started finding out about all of this. So can you go on now to talk about the fourth phase of water and the importance of radiant energy? Because I found that once I understood the connection, it really helped me when I came to the other sections of the book. And then after that, I'd like you to go on to talk about the true function of the heart. So let's begin with, what is fourth phase of water and what's radiant energy and how are the two connected?
Yeah. So we live on a water planet, right? Um, and we're all told, it's like general consensus that we're a large percentage water, life, but specifically humans, we're made up of whatever they say, 70, 80% water. But this water is not necessarily liquid water. So we all know that there are phases of water, or states of water. There's solid, liquid, gas. There's ice, there's liquid water, and then there's steam. But there's actually a fourth phase, or a different state that's more like a gel, kind of between solid and liquid. And that turns out that most of the water in our bodies is actually in this fourth phase state. So how that happens is that, if you have water, and you get it really cold, it will freeze and become a solid. If you get it really hot, it will become steam. It'll evaporate and become steam. And so for fourth phase water, what we need is not necessarily temperature, we need energy. And so we need water, we need a water loving surface or hydrophilic surface, which all surfaces in the body are water loving. And we need energy. And the main source of that energy is, infrared radiation, is what you could say, which makes sense because that's what comes from the sun. And all energy for life on Earth comes from the sun in some way, shape, or form. It all originated from the sun. And so when we have those three things, then when water gets next to that water loving surface, it will actually what's been termed structure itself into this gel-like state of water, on that biological surface. And so most of the water in our cells is in this state. A lot of the water in even the liquid places, the places where there's liquid water in the body, like in the blood, in the lymphatic fluid, and cerebral spinal fluid, there's areas of that are structured too. And it makes sense too, because I don't, like, if I was liquid water, I would feel like a waterbed, right? If you jump on the waterbed, it kind of sloshes around, the water
Yeah.
moves,
Mm,
but I don't feel like that. I have some structure
mm,
to me, but it's
mm,
kind of like Jello, or the consistency of raw egg white, which if I take like the tissue in my forearm and I move it, like it moves like a gel and
mm,
it bounces
mm.
right back, just like a gel.
Sure.
Um, and so that's the state of water in our bodies. And, when you understand that, when you understand the state of water and some of the unique properties or unique characteristics of this state of water, you start to be able to explain a lot of things in the body, one of them being cardiovascular disease, or disease of the vascular system of the body,
Mm,
which
mm,
is what
mm.
I've used it to explain a lot. But you can explain a lot of different things
Yeah.
because of that.
Yes. And so I'm understanding it properly. So is the structured water bit the part that is closest to the wall of the artery or of the vein? And then so is there is there more fluid blood that is running through the center? Is that kind of how it works?
Right. So the blood is about half water. And so that water in the blood, the lining of the artery is a hydrophilic surface.
Yeah.
And so that water that's in the blood will structure itself, given there's enough energy to the body, to the system,
Mm,
it will structure itself on the lining of the artery or the veins or the
mm,
lymphatic vessels.
mm.
And so when it does that, it forms this layer on the lining of the artery that goes around the whole tube of
Yeah.
structured water. So there's more like this
Mm,
gel-like layer that
yes.
kind of does, and it does many things for the artery in that state or being in that position.
Mm. God, brilliant. Okay, thank you. So can you go on now to talk about the true function of the heart? I'm sorry, have we covered how radiant energy helps the water to actually move,
Right,
move along? And so where are we getting, sorry, maybe I mean, where are we
right,
getting that radiant energy from that's going to help it move?
right. Um, well, there's lots of different things that have been shown to increase structured water. And like if people are more interested in this, they can go and check out Dr. Gerald Pollack's work, who's at the University of Washington in Seattle. And he has shown all this stuff. He's actually shown that this does indeed happen on the lining of blood vessels
Mm,
and many other places in nature, this water structuring kind of phenomenon. But yeah, so the structured water does some unique things. So because of the way structured water forms. So we have water, which is an oxygen and two hydrogens.
mm,
And when that water gets next to that hydrophilic surface and the water is sufficiently energized with infrared or radiant energy of some sort, um, then the one of the hydrogens is kind of cleaved off, and we're left with an oxygen and a hydrogen. And those oxygens and hydrogens team up with other oxygens and hydrogens and make this lattice like honeycomb like structure that kind of, and that goes on forever, so it kind of makes this planar structure, and that's what lines up on the surface of the biological water loving surface, kind of lines up, and it's this gel like state. And so because that happens, and so water is a balanced molecule because it has a bigger negative hydrogen and two positive, or bigger negative oxygen and two positive hydrogens, and so that's balanced. Well, when one of those hydrogens leaves, now the structured water is made up of more electronegative molecules of oxygen. And so it's a very electronegatively charged area.
mm,
But then those hydrogens that have left are very positively charged, and they're all concentrated next to it. And so they line up right next to that negatively charged area. And that creates a charge separation, a negatively charged area next to a
mm,
positively charged
mm,
area. And that's a battery. We all know when we put batteries in something, we have to align the positive and negative charges. And so that battery situation actually can, provide energy to the body. It's kind of like the storage form of energy for the body. People think it's ATP, but it's actually structured
mm,
water. That's the
mm.
storage form of negative electrons, negative ions
Right.
that charge the body. And so they've actually shown that you can put an electrode from a light bulb into the negative area, into the positive area of this water, structured water, situation happening, and power a light bulb. So it does indeed provide energy. And
Mm,
so in the case of the blood vessels, they've actually shown in Dr. Pollack's lab that if you put a tube made of a hydrophilic solution into water, and then you shine infrared light on it, the water starts to move through the tube with no pump or anything
oh,
acting upon it. Because the structured water that forms on the lining of that tube actually creates an energy gradient that pushes things through. It does the work of pushing things through the tube. And so this, and they've shown that this blood flow will continue forever if they provide radiant energy to the system, to the water. And so
mm,
that's how the blood moves. For the most part, that's how the blood moves, and that's how lymphatic fluid moves, because there's no pump, quote unquote, pump
mm,
for the lymphatic system. That's how cerebral spinal fluid moves. And there are other things that help with the movement of things, but that's the main way that it moves.
mm, mm.
So then, as
Yeah.
you were alluding to, that makes us question, well, then what is the heart? Why is it
Yes,
there?
exactly. So that was what I was going to ask you to go on to the sort of true function of the heart. Now, I should say at this point, my dad, I mean, he's passed away now, but my dad was really tall. So he was like 6'5" and a bit. And
Mhm.
he had very, very long legs. And when I was reading your book, I was thinking, well, yeah, when I apply this concept to my dad, how on earth could his heart pump all that blood down to his toes and back? I mean, it just doesn't make any sense, really. And so I kind of I just feel that when I've read your book and I've read that back and I thought, oh my goodness, it's kind of, I don't know why people haven't questioned this before, because when you explain it, it does seem very obvious. And yet we just assume, because we've always been told that the heart is what pumps the blood around the body. So anyway, so I just wanted to just to use my dad as like
Mhm.
an example as to how it could be that actually we need to think about this in a completely different way. So can you go on now to explain, please, the true function of the heart?
Definitely. Yeah. So, it's, I guess, if you just kind of observe it from the outside, you see this organ contracting and blood moving through it, and you're like, oh, it's contracting to pump the blood. That's what moves the blood. Okay. So you can kind of see how that happened. However, there's really no evidence that it's it can create enough energy or force to move the blood throughout the entire body, no matter how tall you are. But yes, in a person who's 6'5", like if I was gonna, like, from an engineer perspective, if I was going to pump water up a hill, like from my toes back to my heart, I wouldn't put the pump at the top of the
No.
hill and pump it down the hill and then back up.
Mm,
That wouldn't make sense. That's not very
mm,
efficient.
mm,
And that's because that's not what the heart's job is. It's not to move the blood. It
mm,
does do a very small amount of pumping, but it's no more than just enough to move the blood through the chambers of the heart itself. Once the blood gets back out into the blood vessels, then this fourth phase water mechanism on the lining of the blood vessels is what takes it up and moves it through. Now, there are other things that create blood flow, like electrostatic properties of blood and paramagnetism and things like that. But the main way is the structured water. And so then that begs the question of, what is the heart and why is it there? Why is it contracting like it is?
mm,
And so there's three main roles of the heart, in my opinion, none of which are to forcefully pump blood around the body. One is to vortex the blood. So there are different ways that water can gain energy, and one of them is infrared light. But another one is what's called vortexing the blood in the presence of oxygen, which there's always oxygen present in the blood. Even if
mm,
it's venous blood, there's still oxygen present. And so when the blood moves through the heart, it's actually vortexed or spiraled. So like, if you've ever taken like a 2 liter bottle and you swirl it around and it makes that vortex, and that's what I'm talking about. We're vortexing the water, and that does energize it so that when it gets next to the blood vessels out in the vascular system, then it can structure itself and provide blood flow. And so that's what the heart does. And if you see like optimal vortex formation of blood as it moves through the heart is an indication of good heart function. And there's actually studies that show that. And so the heart is actually this one big band of muscle that's just wrapped up on itself. And so when a signal to contract comes through it, it actually kind of spirals like this, and so it's twisting the blood. But also when blood moves through the valves, and when it flows past itself in different arteries, like when it meets through the vena cava, it like swirls, like it creates all this turbulence. And so that turbulence of the blood is what energizes it, vortex. So the heart is a vortexing hydraulic ram, which is another sort of like, it's kind of, they call it like a hydraulic ram pump, even though it's not really a pump,
mm,
but a hydraulic ram. You can look it up on YouTube, like how it functions.
mm,
It's an engineering device, but a hydraulic ram is flow activated. So it only works if there's constant flow into the device, which is what we're talking about. We're talking about the movement of the blood flowing by other mechanisms into the heart itself, activating this hydraulic ram. And then there's a signal from the brain that signals for it to contract, so that it does the vortexing. So that's the first role of the heart, is to vortex the blood. The second role of the heart is actually to slow the flow of blood.
mm,
There's actually a lot of experiments showing that in times of exertion, where I'm exercising, that my tissues are demanding a lot of nutrients. They want oxygen, they want nutrients for fuel. And so if I didn't have a heart there to slow the flow of blood, then all the blood would rush over to the arterial side, delivering nutrients to tissues so that I could perform that movement. And
Mm.
if the heart wasn't there stopping it, then the venous side would collapse because there wouldn't be enough, fluid, blood in that side to keep it open, to actually maintain the hydraulic pressure that it needs to keep it open. It would collapse and we would die. And so the heart has actually been shown especially in endurance athletes, to slow the flow of blood when we're under exertion. And that's the reason why in endurance athletes, when we see this cardiac hypertrophy where the muscle gets kind of big, it's actually, they've shown that it gets big because it's more effective at stopping the flow of blood,
Mm.
not because it's better at pumping the blood. So our muscle has to be bigger to stop the flow. And then the third role of the heart is actually to measure what's called coherence or body communication. So the heart, all organs emit an electromagnetic field because depending on like how big depends on their mitochondrial content. And the heart has the highest mitochondria of any. Well, it's the eyes are pretty big and the brain's pretty big too,
Mm.
but the heart is the biggest as far as the most amount of mitochondria, and it's a fairly big organ, so it has the highest electromagnetic field of any organ in the body,
Wow.
and even bigger than the brains. That they estimate about 5,000 times stronger than the brains, and so it's
Mm.
the only electromagnetic field that's large enough to kind of sense everything in the body. Like all the cells are able to, the heart's able to sense every single cell in the body, and that
Wow.
gives it the ability to measure what's called coherence, or measure the amount of communication, interbody communication between cells and things like that in the body. And so, based on how well things are communicating, your heart is picking that up. It's also picking up things from outside the body. So, maybe people in the room next to us. It's picking up other life. It's picking up, unfortunately, signals that aren't so coherent to us these days. Things from modern life, and it's picking up that or measuring that coherence and then relaying that information to the brain. And there's studies that show that there is more signals from the heart to the brain than the brain to the heart.
Wow.
And so that's what's telling your body basically if we're in a safer, threatening environment.
Mm.
And so that could come from internal coherence or external coherence. So signals from outside or inside the body. So that's the third role of the heart,
Wow.
but very different than what we're told. And the reason this is important is that if we've misunderstood, the real function of the heart and the body, how are we ever supposed to understand what happens when it goes wrong?
Mm.
Like when we get things like vascular disease or heart failure or cardiac arrest or arrhythmias, like how are we supposed to understand those things if we don't really
Mm.
understand
Mm.
how the heart functions
How it
and why
functions,
it's
yeah,
there?
what its role is. Yeah. So it seems like it's sort of managing that whole situation, really, isn't it? The whole situation within the body. It's kind of keeping everything balanced.
Yeah, it's monitoring blood flow, so that it can slow it and speed it up based on what it seems appropriate. It's vortexing the blood so that the mechanisms.
Mm.
So in a
Mm.
way, the blood is responsible for the movement of blood, or the heart is responsible for the movement of blood. It just does so in a very different way than we
Yeah.
think it does because it's vortexing. But a vortexing heart is not near enough energy created for blood to
Mm.
keep the blood moving. We also need
Mm.
external energy sources, which is the sun pretty
Yeah.
much, because the sun is 40 to 50% infrared light at all times. So we need that stimulus as well. Um, and yeah, so it's kind of, and then it's monitoring kind of our emotional state. There's a reason we say things like "I love you with all my heart" and not "I love you with all my kidney" or whatever. Um, and so it's measuring the emotional state, it's measuring
Mm.
coherence. It's yeah. I mean, there's it's doing a lot. And I
Mm.
think there's a reason why we say things like we're at the heart of the matter, you know,
Mm.
we're, the heart of the problem, things like that. We're finding
Yeah.
because I think the heart is the most important organ in the body because it's regulating all those things. And obviously the other organs
Mm.
are very important too. But we've kind of had this top-down mentality of the brain's
Yeah.
controlling everything. But the brain
Yeah.
is just an interpreter system. It's basically,
Mm.
I compare it to like the mail or the post, like you guys call it. So it's basically like the postal service is not changing or creating information. They're just receiving the information,
Mm.
seeing what it tells them to do, and relaying it somewhere else. That's what the
Yeah.
brain does. It's not in control. What's in control, or what
Mm.
dictates what the brain does, is the information it receives from outside the body or from the sensory information
Mm.
inside the body. And so if we want to change what the brain is telling our body to do, whether it's a symptom or not a symptom, we have to change the environment and what our
Yeah.
senses are picking up. And one of those senses is the heart.
Is the heart.
Yeah.
Yeah.
So
Yeah.
it's very interesting when you think about it like
Yeah,
that.
absolutely. And it does make you wonder because we have all these sayings. So you think, well, at some point in the past, people must have realized, how the heart coordinates so much. And yet we seem to have lost touch with that, really, don't we? I guess because I don't know. We just seem to have taken a completely different route as to what the role of the heart is. And yeah, so let's just go on now just to talk about the heart when it's not so well.
Mm,
So can we talk about what causes atherosclerosis? And you could bring into this as well your own experiences to
mhm,
talk about that. And after that, can you talk about the experiences that you had with your leg
mhm.
sometime after you had your heart problem?
Yeah. Um, yeah. So atherosclerosis, we people talk about, so that's plaque forming in the arteries, and that's one form of heart disease. There's other forms. There's heart attacks, there's cardiac arrest, there's vascular disease like stroke, there's arrhythmias, heart failure, lots of different forms. But when we're talking about atherosclerosis, that's plaque forming on an artery, regardless of where it forms. But the famous one is coronary plaque, plaque
Mm,
on the arteries of the heart, which it happens most commonly there because the heart arteries are under the most pressure of any artery in the entire body. And so when things do go wrong, that pressure puts them under more stress, more. So the theory is that cholesterol, we get high cholesterol, and that gets stuck on the lining of our arteries, and that's what causes heart disease. And that's been the theory,
mm,
but it's only ever been a theory. It's never been proven. Matter of fact, it's been disproven quite
yes.
abundantly. And it was a theory because I mean, the history of it is that America, heart disease was growing quite rapidly in the 50s, and they kind of frantically came to try to give an explanation for this. And, Ansel Keys gave us the explanation, which was based on some very faulty science. But there was a lot of money behind this theory from pharmaceutical and food industry. And so the theory just kind of took off that cholesterol caused heart disease, even though when they, pretty thoroughly tested it,
Mm,
but in like the early 60s to mid 70s, the studies show that it wasn't really the case. But the theory taken off and there was money behind it. So then it's not cholesterol. And we have lots of evidence today that, it doesn't matter what your cholesterol is, whether you get atherosclerosis depends on many other factors. And people with high cholesterol get just as much disease as people with low cholesterol. And
mm,
so it doesn't really correlate at all. So the question is then, what does cause
mm,
atherosclerosis? And if you think about it, like the end game that everybody's trying to prevent is a heart attack, a stroke, is atherosclerosis in arteries, which all of that stuff is clotting tissue. So it's the same type of tissue, more or less, that when you cut your skin and a scab forms, a clot forms to stop the bleeding. So
mm,
the same thing happens in the blood. We just get pathologic clotting that happens. Now, this can happen slowly over time by getting damage to an artery. And if the artery is overwhelmingly damaged or it can't repair itself because of other things like type 2 diabetes, then the body is forced to do something else. And so it has to patch it up, just like it does when you cut your skin,
mm,
by making scar tissue or clotting tissue or a scab, on that spot. And if you analyze atherosclerosis in people on autopsy, that's what it is. It's like 87% clotting tissue. And there may or may not be some cholesterol present, but it's just no more than enough that was just around when the clot formed and got stuck in there. Or
mm.
sometimes it's used as kind of the immune process of that healing and the clotting forming. So it's used in the process, but it's not the driver of the process. So then we
Right.
have to ask ourselves,
Mm, mm,
well, what causes clotting,
mm,
right? And so back in 1856, way back in the day, Rudolf Virchow, scientist, physician, found that the things that perpetuate clotting are when we get damage to the lining of the artery, when we get poor or stagnant blood flow, and when we get elements of blood that are too sticky, they're too clumped together.
Mm.
And so if you look at some of the properties of structured water in the artery, it helps us understand that a lack of structured water is what's perpetuating heart disease, plaque forming, that clotting that's happening. And if it happens very acutely, very rapidly, it can happen like a heart attack, can happen, a clot can form. And so, because of the way structured water forms, they call it exclusion zone water too, because nothing can really penetrate it. The only thing that can get through
Mm.
it are small hydrated ions of minerals. And so when it forms on the lining of the artery, it's like this protective barrier. So if we have that protective barrier there, then nothing can really damage the lining of the artery, which is Virchow's triad number one: protect the lining of the artery, don't cause damage. We've already talked about how structured water creates blood flow. And so the second aspect of Virchow's triad is to create adequate blood flow and stop blood from being stagnant or getting interrupted blood flow. So we want to build structured water so we get adequate blood flow. And then the third is structured water also forms on the elements of blood, like red blood cells and lipoproteins, because those are hydrophilic water loving surfaces too. And so when they do that, we get this, like the red blood cells each have this negative charge around them, because the structured water is on there. So that gives it a negative charge. And two things that have similar charges, they repel each other. They stay away from
Mm.
each other, right? And so that's Virchow's triad number three, is when we keep the elements of blood evenly spaced and not clumped up or sticking together. So if we build structured water in the body, we prevent these things that increase risk for clotting. And so we have to ask ourselves then, is heart disease a result of high cholesterol, which there's no evidence for,
Mm.
or is it a result of lack of structured water in the body? Which then takes us to, is it a lack of radiant energy to the body? Is that what it is? Is it a lack of basically sunlight exposure?
Mm.
As
Mm.
humans have gradually um, eaten more inflammatory diets and then also moved indoors, right?
Mm.
We've moved inside, we're out of the sun, and then even more recently, we've gotten artificial light. We had incandescent for a long time, but now we have this artificial blue light,
Yeah.
which is really, and there's lots of research showing that lack of sunlight and artificial blue light exposure, both of those things are driving the pathology of the arterial lining.
Mm.
And so it
Mm.
all makes sense when you think about it in the context of structured water. So it's clotting. And so, like you alluded to, yes, at age 34, I actually had a heart attack, despite my best efforts of just changing my
Mm.
diet, right? And that was a very important part of my health journey. And, diet is very, very important. However, it was not enough to prevent pathologic clotting in me. And, people think that this atherosclerosis builds up in a coronary artery and eventually gets so small that it just blocks an artery or a piece breaks off. And I found a lot of evidence that that's not really true, that that's not how most heart attacks happen. And personally, my N of one experiment for me was that I had no calcified plaque in my artery. I had no even soft plaque in my artery,
Wow.
um, and a giant clot just formed and it blocked the
Mm.
artery in my heart and it gave me a heart attack.
Right.
Obviously, I survived,
Mm.
and I'm here today. But it was because I was so focused on preventing disease with diet, and that was the only thing I was doing, which again is very important. But I was
Mm.
not doing a bunch of other things that build structured water in the body, and I got into a situation of very high stress, of dehydration,
Mm.
and then I did unwisely did a workout that morning, and I talk about this all in my book.
Mm. Yeah.
Um, but and then when I did that, it was kind of the straw that broke the camel's back, and that clot formed. And again, it happens more likely in coronary arteries because they're under the most pressure of any artery in the body. And so that was the case. That's
Right.
what it was.
Okay.
And
Yeah.
and so yeah, and then because of that, so when they went into my groin to place to go into that artery so they can go up into the heart and bust the
Mm.
clot when I was having the heart attack,
Mm.
they went in through the femoral artery in my groin, and they used a device called the angioseal to seal up the artery afterwards. And the reason they use that device is because otherwise I'd have to lay on my back for, I think it's over 48 hours, which for a lot of people laying stagnant like that, you
Gosh.
get
Yeah.
clotting issues
Yeah.
when you're laying in a hospital bed,
Mm.
which should be the
Mm.
signal right there that it's not
Mm.
about
Mm.
cholesterol. It's
Mm.
about
Yeah.
being stagnant, right?
Mm. Mm.
Not having moving blood. But anyways, um, but they use that device, and I found evidence that that device, it kind of constricts the artery a little bit, and there's a little part of it that kind of sits on the inside, like this, inside of the tube. And so when blood flows past that device, it kind of interrupts blood flow and creates this stagnant
Oh,
area of blood. And I developed atherosclerosis in my leg, a narrowing of the artery in my
oh
leg, my upper thigh.
gosh.
And so then
Mm,
I didn't have no idea this was happening or whatever. And I started, walking again after the heart attack, about 2 months after the heart attack,
mm,
and
mm,
my leg had extreme pain in it,
mm,
because I couldn't walk. And so, because I was not getting blood flow to my leg. And so I thought, I don't know, what is this? Like a deep vein thrombosis? Am I have compartment syndrome? What's going on?
mm.
And I finally figured out that it was this atherosclerosis that formed. And they tried to tell me that it wasn't the device
Gosh.
and they weren't going to take it out and all this stuff. And and they were like, well, you got this atherosclerosis there. We could bypass it or stent it, but usually when we do that, it just get worse. And it was interfering with my ability to like go hiking and play soccer and things like that. But it wasn't interfering with my day to day. So I was like, we'll just leave it alone. And I started doing things that I know help the artery heal. And this is the time in my life when I really started doing things like more sunlight and grounding, infrared sauna, red light panels, those types of things, especially on that spot in my leg. And so I started doing that. And so when they originally tested it, there was a 75 to 99% blockage of the artery in my leg. And
Mm,
so a year later, after I was doing all these things, and that's the only thing I changed. I didn't change
mm,
my diet. It was still very animal based.
mm,
My
mm,
stress stayed about the same, unfortunately.
mm,
Most other things stayed about the same. And the only thing I
mm,
changed was doing these more light therapies. And
mm.
so a year later, they did the test again, and it was only 50% narrowed, only 50%
Yeah.
blocked. And at that
Mm.
time, they told me, well, we can't say that it's better because we just don't see these things get better. And I was like, well, the test just showed that it's better. And so then another year goes by that we did the test again, and it was normal. My artery was normal. It went from 75 to 99% blocked to completely normal. And I want to say and make and point out that all I did was change my light environment. And since I eat a very low carb kind of animal based diet, I'm what Dave Feldman has called a lean
Yeah.
mass hyperresponder. So my total cholesterol and LDL cholesterol
Mm,
levels during these two
mm,
years
mm,
were much higher than what is recommended.
mm.
There are times when
Right.
it was my LDL was over 300, which they want at 100 or
Mm,
lower in
mm,
United States
mm,
levels. And so while I was healing atherosclerosis in my leg, my cholesterol was well above normal. And I have 4 tests
mm.
during those 2 years that show that it was well above normal. So again,
Right.
it's just the end of one
Yeah.
experiment.
Yeah.
It's just me,
But it
one
does make you
person.
question. Yeah.
However, it's proof that it is possible and
Mm,
that cholesterol is not like if that was driving heart disease, then
mm,
then my artery would continue to get worse,
yeah.
right? But it didn't. I
It didn't.
completely reversed it.
Yeah.
So we have to stop and think about that. And if a physician hears that story and doesn't think, well, how did that happen or
Doesn't ask
why, or not
why.
have any curiosity, then you need to find a new
Yeah.
physician.
Yeah.
So yeah, that's
Absolutely.
kind of the story
Yes.
there.
Yes, yes. And I think that people have become far too focused on LDL and cholesterol, really, haven't they? Like you, I'm also a lean mass hyperresponder, and my doctor was really most upset when my numbers came through. But when I tried to explain to him, look, my triglycerides are low, my HDL is high, and everything else is absolutely fine. So I just don't, but you know, they just get fixated, don't they? And they just said, well, I'm just worried about you dropping dead of a heart attack.
Yeah.
So
Yeah, well, it's
that,
it's ridiculous because, when you look at it that way, like that, being that myopic about it and just looking at that one marker, that's really reductionist in thinking. To think that
exactly.
a disease process is caused by one biomolecule in the
Yeah.
body, like that's just ridiculous, really.
No, it is.
Yeah, and the theory never really had any sound evidence behind it. All it had was money
Ah,
behind it,
mm,
and now the standard of care
exactly.
is if someone has high cholesterol and you don't recommend a statin and something happens to them, you're liable. So
Mm.
now there's fear from the physician, and that fear is translated
Right.
over to the patient. If you
Yeah.
don't do this, you'll get a heart attack when
Mm,
there's no
mm,
evidence behind that.
no.
And clearly it's not working. because in westernized
Yeah.
countries, especially the United
Mm,
States, where we take 80% of the world's drugs, and statin drugs are either one or two,
mm,
as far as most highly prescribed medications, it's not working because heart disease
no,
rates continue to be very, very high.
yeah. Mm,
And I would argue even getting worse depending on how you
yeah.
categorize heart disease.
Yeah.
So it's not the answer. And
Mm,
there's studies that show that. There's studies that show that
yeah.
cholesterol is not associated with heart disease, is actually associated
Mm,
with better health,
yeah.
and that lower cholesterol doesn't work to prevent heart
Mm,
disease,
mm,
vascular disease, or heart attacks, or anything like that.
mm,
And so we need a better theory. We need, like as you said in the beginning, to open up this conversation about heart
yes,
disease and actually ask
definitely.
ourselves what's
Mm,
going on. And
what's going
unfortunately,
on? Yeah.
the system that we rely
Mm,
on for that
mm,
answer
mm,
is lost
mm,
in itself. And there's
yeah.
things in place that keep it from thinking outside the box. And so it's kind of on us as individuals, to
Mm,
take
mm,
back control of our health and not rely on that system so much. And when
yeah.
I was in the hospital with a heart attack, which my heart completely fully recovered 100% within 3 months, and I didn't take any of the medications they recommended. Well, I took a blood thinner for 6 months because there was a stent in there,
Mm,
and I wanted to prevent any pathologic clotting.
mm, mm,
But other than that, they said that I'd be on the blood thinner and blood pressure medications and a statin, cholesterol drug, for the rest of my life, and a baby aspirin the rest of my life. And
wow.
I don't take any of those things, and my heart fully recovered. And again, that's just me. That's just an N of
Yeah.
one experiment,
Mm,
that
mm,
I
mm,
was confident enough to make that decision.
yeah.
But it also should make us question, well, like if they're so
Absolutely.
sure, because I was told
Mm.
in the hospital, if you don't take these medications and you don't eat a plant-based diet, then you're gonna
Oh
die,
my goodness,
basically is what they
really?
told me. Like
Crikey.
they gave me a list of foods I could eat, I was allowed to eat, and it was
Mm,
all low
mm.
salt, low animal foods. There was like a bunch of processed
It's
food, vegetable oils,
crazy, isn't
grains, and
it?
I was just like, this
Yeah.
is the complete wrong diet.
Yeah.
um and I didn't do any of that, and my heart fully
Mm.
recovered, and I reversed
Yeah.
atherosclerosis in my leg.
Yeah.
So
Mm.
there's more than what we're being told,
Yeah,
and that's the important thing to
absolutely.
realize.
Absolutely. But I feel that, I mean, this is one of the reasons why this book is so important because so many people have failed to make those connections. I mean, I only yesterday I was thinking about back in the 80s, here in the UK, the law around workplaces was changed because they realized that some buildings had something called sick building syndrome. And what that came down to was buildings without windows.
Mm,
And what they said was that no, that is causing this sick building syndrome, or one of the reasons that's causing the sick building syndrome. So after that, they brought this law in that said that every building essentially had to have windows, had to have natural light. So,
yeah.
so they realized then what the importance of natural light was.
Mhm.
But as I say, it's not until you've come along and written this book that we've started to put things together, and that is the importance of having these conversations and getting the word out there so that we get a lot more medical people asking the question why, which is what they don't seem to do really very much at the moment.
Yeah.
Um, so next, I'd like to go on to talk about free radicals, oxidative stress, and ages. And I feel that people have probably heard about free radicals and oxidative stress, but they probably haven't heard about AGEs. So
Mm.
could you just go touch on all of those and just let us know what they are and why they're important?
Yeah. So, um, you know, I was talking about structured water and how it holds a charge, right? And it's a negative
Mm,
charge, is what it holds. And everybody who learns cellular physiology knows that our cells operate best at a net negative charge. And this negative charge is held in the body by structured water. If we have, enough structured water formation in the body, we hold this negative charge and our cells function properly. Um, Now, so it's all about gaining that charge of electrons, right? Now, there are certain things in the body that are made in the process of making energy, that are called free radicals. And these free radicals are just molecules that have an unpaired electron, and they're so that means they're unstable. If they have a
mm,
pair, they're stable. Um, and so they're looking for that pair. They want to steal it from anywhere. And so if we have, you know, these free radicals being produced in the natural process of metabolism, or various things that can come from outside the body into the body and act like free radicals, like toxins, like heavy metals and things like
Mm,
that.
mm,
Or if we get damage to certain molecules, like from too much, like too high glucose in the body, we can get advanced glycation in projects, the ages you were talking about,
mm,
and those things can become act like free radicals. So there's a situation where we can have this a bunch of these molecules that are requiring this electron to stabilize themselves. And so what they do is they end up stealing electrons from other things to do that. They're very reactive in that way. And so one of the biggest places that they can steal electron from is structured water. It's very electronegatively charged. And so that can, if we get this abundance of free radicals, that can steal our negative charge. If we're doing things like we're getting toxin exposure, we're eating a processed food, high carbohydrate diet, if we have the high blood sugars and things like that. If we're doing all these inflammatory things and creating too many free radicals, then we can start to lower our charge. And that's also perpetuated by the fact that we're removed from the environment that restores that charge,
mm,
which is we're out of the sunlight. We're not in a metabolically flexible state of metabolism. We're not in touch with the earth. We're under artificial light. We're surrounded by electromagnetic fields and non-native electromagnetic fields, things like that. However, because of that situation, free radicals kind of get this bad rap. They're these bad things in the body, but they're not bad things. They actually do a lot of good things for us. They're signaling molecules. They signal for satiation in the body based on how much, how many free radicals are produced in metabolism. They can signal for your body that you're satiated um, or unsatiated. They're also communication molecules. They can communicate different things to the body. They can communicate molecule to molecule, or they can communicate through resonance. Like you tune into a radio station, you can get that wireless signal. They can communicate, electromagnetically. They're signaling molecules. They give your body information. So we need these things. They're not bad. They're only a problem when we do things that create an abundance of them, and it kind of overwhelms the system and results in very low body charge. And so if we want to increase that charge, we have to do the things I talked about. You put yourself in the environment that increases the
mm.
charge and do things that remove the free radicals. So that's like avoid toxin exposure, and eat a metabolically flexible diet, that kind of stuff.
Mm. Okay. Right. Yes. Good. So from what I understand from reading the book, when we get a excess of these, they can move into the vagus nerve. Is that correct?
An excess of free radicals.
Yes. Is it an excess of free radicals that can move
I mean,
into the vagus?
that's one thing that can trigger a kind of an incoherent stress state to the body, that the heart's picking
Right.
up and then conveying to the
Yeah.
brain. And then the vagus nerve is what communicates, okay, we're in a stress state. So that's
Yes.
not a good thing. Yeah.
Okay. And so these AGEs, where are they coming from?
Yeah. So most of the time, I mean, you can eat an AGE if
Mm,
you eat a lot of burnt food, especially
right.
burnt carbohydrate food,
Mm,
like bread crust.
mm,
That's the Maillard reaction. That's a burnt carbohydrate.
mm,
But also if you like, severely burn a steak, things like that, those
mm,
are AGEs. And so those things in small amounts can be seen as a hormetic stress, which your body responds to in a more positive way. So it ends up being a net positive thing. Like it responds by making a ton of antioxidants. The body makes those antioxidants.
mm,
So that can be seen as a good thing. But if we get too much exposure to these things, then that's a problem. Now, the other
mm,
way we can get AGEs is if our blood sugar is too high.
right.
So advanced glycation is the key word
Mm,
in products,
mm,
are what AGEs are. And so AGEs, they can come from too much glycation or too much saturation of glucose. So like if people are familiar with diabetes, and one marker they take is a hemoglobin A1C,
yeah.
and that A1C is basically measuring the percentage of your red blood cells that have been saturated by glucose. They have been
Mm,
glycated. by glucose because your blood sugar is too high. And it's supposed to be a certain percentage of those red blood cells will
Mm,
become saturated with glucose, anywhere from 4.5 to 5.5 in American numbers,
mm,
percent of those. But if it starts to be higher than that, it means that our blood
mm,
sugar has been higher over the last 3 or 4 months.
yeah.
And so it's measuring the amount of glycation. Now, other things can become glycated too. If we have high blood sugars, not just the red blood cells that can become glycated, lots of different things can become damaged by glucose. And
Mm,
those things that are damaged by glucose are advanced glycation end products that act like free radicals, and
mm,
become damaging to the body. And there's studies that actually show that those things can initiate damage to the lining of the artery,
mm,
and perpetuate or start the process of atherosclerosis.
right,
So, but
right.
it's all just damage to the structured water, then damage to the glycocalyx, then damage to the lining of the artery. All these things are just damaging it. So we have
Yes,
to
yes.
prevent those type things.
And so if you want to prevent those too many free radicals, oxidative stress, ages, how would we, what's the best way to make sure that we're not getting either any of them or too many of them?
Yeah. Um, Avoid toxin exposure,
Mm,
for sure. Or like eating, overly processed foods. That's where we're going to get
yes.
damage to or that's when you get exposure to a lot of
Mm,
toxins and damage to the sugars in those processed foods that result in AGEs. And then keeping our blood sugars normal. And so that they're not there's not excessive glucose in the blood. But
mm,
you could have excessive glucose in the blood, long before they tell you that you're type 2 diabetic,
yeah.
And so we want to do that. And so the best way we do that is it's twofold. One is we eat a lower carbohydrate diet. And if you think about it, generally humans would not have had access to the amount of carbohydrates that we have. For the
Sure.
vast majority of time that humans have been on the
Yeah.
earth, we would have eaten animal foods, very low carb,
Mm,
and we would have had
mm,
access to some carbohydrates in the form of fruit at one time of
mm,
year for a few months out of the year. And
mm,
so it's not that carbohydrates are evil, but they're definitely not supposed to be eaten in the levels that we're eating them,
yeah.
especially not grains and processed sugars and things
Yeah.
like that.
Mm,
So that's one way that we maintain blood sugars is we eat a lower carb, metabolically flexible
mm,
diet,
mm,
which I
mm,
think higher in animal foods is always best.
yeah.
And then the other way is we change our light environment. There is a
Mm,
ton of literature showing that our altered light environments, mainly artificial light after sunset, is incredibly
mm,
disruptive to our metabolic health.
mm,
And it's part of what's driving our epidemic of metabolic diseases,
mm,
specifically type 2 diabetes, but even insulin resistance and leptin resistance well before it becomes type 2 diabetes. So
right.
optimizing your circadian rhythm and
Yeah.
being very conscious of your light environment is an incredibly
Mm,
important thing. And it's just as important as diet, when it comes
mm.
to creating metabolic health and keeping blood sugars normal.
Mm, mm. And it's funny you should say that, but growing up, my mum and my grandma lived well into their 90s. They were like 97, 98, when they sadly passed away. But I just remember growing up, I used to be constantly complaining once it got to dusk because we would be living in this like semi-darkness
Mhm.
because they just did not want to put lights on.
Mhm.
They just would not put lights on. And literally you had to walk into a room and the room had to be like pitch black
Mhm.
before they would let anybody put a light on. And my mum, she'd never closed her curtain. She always said she liked to wake up to the natural light. And at every possibility, she would go without shoes and socks. She was
Mhm.
always walking around without her shoes and socks on.
Mhm.
And now, these are all the things that I would say, oh, Mum, for God's sake, my
Mhm.
God, you just. But now I'm thinking, well, she got to 97. So,
Yeah.
she clearly knew, I think, in our grandparents, our great grandparents, I think knew more about what a healthy life was than we seem to today, really.
Yeah, I think that we kind of write them off. Oh, they're just stubborn. They're set in their ways. And maybe it's because, they just feel better when they do that. And so that
Yeah.
keeps them doing it. And people will say, well, where's the research behind that, or all these different things. And it's like, humans made it this far without research.
Yeah,
And we
exactly.
thrived because in order to become what we have become and the numbers that we have, we had to have been
Mm,
thriving.
mm,
And so it's funny that it's not until this whole world of research came along telling us what to do and what's right that we've
mm.
gotten so sick.
Yeah, exactly.
So it's like, where are we, putting our faith in? Are we putting it in all this research, or
Mm,
just the natural wisdom of, hey, where did humans come from? We
mm,
didn't come
yeah.
from living indoors under artificial light all this time.
Mm,
We came from an environment that was the only light we had was sunlight, and then fire, which
mm,
is not strong enough to turn off your or set off your circadian
yeah.
rhythm, or
Mm,
disrupt
mm,
it. And we had natural food; it was the only choice we had. We ate it in season.
yeah.
We were outside in contact with the earth. We were moving our bodies all the
Mm,
time. And
mm.
it's just like, what makes more sense? These randomized controlled trials that were human designed, or the fact that humans that live out in the woods are just
Mm,
healthier than the ones that live in civilization?
yeah,
Like, what makes more sense? Like,
exactly.
what more do you need to
Exactly.
know?
I know, exactly, exactly. Yeah, quite. Yeah, very true. And when I think back to, what my grandparents and my mum would talk about how what they ate when mum was growing up, and they would quite often have at supper time, so after dinner at supper time, they would quite often have chips, but
Hmm.
those chips were always cooked in lard or beef tallow.
Hmm.
So, I remember, up until I went to college, we never cooked with vegetable oils. It was only ever, well, hardly ever butter, because mum said, oh, butter's too expensive, but it was always lard or it was beef dripping. And
Hmm.
that was always what our food was cooked in.
Yeah.
Always.
Yeah.
So you have got to wonder, haven't you, how these
Yeah.
people made it to like
Well,
almost 100.
yeah, and it's just logic too. It's like heart disease. People don't realize that heart disease in the early 1900s was not a thing.
Mm,
It was not
mm,
this disease process that we know. It's not an
mm,
epidemic,
mm,
It
mm,
was very
mm.
few people had heart disease. There was no like American College of Cardiology. There was none of that
No.
stuff. There was a few doctors
Mm,
maybe interested in the heart. And then
yeah.
around the middle of the century, heart disease started to rise. So
Mm,
before that time, when we were living outside, eating a ton of animal foods, like heart disease was non-existent. And now
mm,
that we're living in civilization, heart disease is an
yeah.
epidemic. So
Yes.
what like the logic behind that? That's the most
Yeah.
fundamental, logical thing you can look at, because you can get all lost in the weeds with all the details of the studies, and you can design a study
Yeah.
to pretty much show anything you want to.
Exactly.
Um, so we have to
Mm,
kind of go back to that wisdom,
yeah,
and stop
we
getting lost
do.
in the
Definitely.
details.
Yeah, definitely. And my mum used to tell me this story about when she was about 14, she complained that she was too skinny. And of course, she said, in those days, everybody was really skinny, but she was very skinny. So she insisted on my grandma taking her to the doctors to find out, if there was something wrong with her. And the doctor said, no, there's nothing wrong with you at all. He said, you should be able to count every rib. That's what he
Mm,
said to, to,
mm,
to my grandma. Should be able to count every single rib.
yeah.
But I don't even know if I can count every rib, every
Yeah.
rib.
Yeah.
But so that just goes to show, really, doesn't it, that,
Yeah.
we're all, I think it is, like we were saying at the beginning of our conversation, it's trying to navigate your way through the modern world. I say this to all my clients. If I take a new client on, and I explain to them how, it is about getting that balance right. And it's about, in actual fact, I think people in the past had it much easier than we've got it now, because if there was a lack of food, well, then there was a lack of food, then people just didn't eat. But now there's such an abundance of food, and oh, you want something, you can have it in 2 or 3 minutes. It can be
Mm,
at your front door. So there's no need to wait, you don't have to think, oh, am I really hungry? Do I really want to eat this? It's just instant, it's instantaneous, and there's just an abundance of really unhealthy food just everywhere, really, isn't there?
yeah, definitely.
So can we move on to, have we got time to talk about blood pressure and what the signals of blood pressure in the context of health and maybe poor health?
Yeah. So, blood pressure, um, you know, people say, oh, it's so dangerous to have high blood pressure. And, I'm not going to say that it's not dangerous, but somebody with high blood pressure, we wouldn't tell them, oh, don't work out, right?
No.
We'd say, oh, maybe you do need to work out to increase your health
Mm,
or whatever. So
mm,
in that sense, we're not afraid for them to drastically increase their blood pressure, in an acute situation where they exercise. So I've always questioned, is it the high blood pressure that's so dangerous, or is it the things that are causing the high blood pressure that are the more dangerous, the ones that are predisposing us to, the end stage clotting events that people are worried about? And it's the things that cause high blood pressure. So we have to ask ourselves, what does that?
mm,
And you know, there's a few different things. Um, One is a state of insulin resistance, seems to be very heavily
mm,
associated with high blood pressure. And so that's type 2 diabetes, is what we're talking about there, insulin resistance. But to me, the real cause of high blood pressure is lack of structured water on the artery lining. Because, like we've talked about, that structured water is there and it's creating blood flow. It's making blood move. If we
mm,
if we lose that structured water and we get damage to an artery, which is why insulin resistance is associated with this, because insulin resistance impairs the ability of the lining of the artery to repair itself when there is damage. So if damage happens and we also
mm,
can't repair that damage, then we're more likely to get plaque formation. But all that damage is happening because we've lost structured water on the artery, or it's not as
mm,
robust as it should be.
mm, mm,
And when that happens, we also get poor blood flow. And so if we get poor blood flow because we've lost the structured water, so those mechanisms are
mm,
not moving the water along, um, then we get poor blood flow. And so what does the body do to increase the blood flow? It constricts the artery. And when you
mm,
constrict the artery, you create more pressure. Just like if I had a hose and I put my thumb over the hose and decrease
mm,
the amount
mm,
of area that the water had to move through, it comes out faster,
mm.
right? So the same kind of thing happens. We restrict the area
Ah,
and it flows
right.
faster,
Yeah.
right? It makes
Mm,
the blood flow, but that also increases the pressure.
mm,
And
mm,
so that's
mm,
what's causing high blood pressure. You break down that structured water.
mm.
And then we've talked about all the mechanisms by which that water can be broken down.
Yeah.
So that's the main one. But then, it's associated with a lot of different things. It's associated with
Mm,
stress because obviously, in a state of stress, your body's trying to deliver blood to tissues because it thinks it's under a threat, trying
mm,
to deliver the blood to the tissues more quickly. So again, it constricts the arteries, and
mm,
moves things
mm.
more
And
quickly.
and so what happens to the heart? So when somebody has high blood pressure, what happens to the heart? Is there something that happens to the heart in that situation? Are the vessels within the heart also narrowed?
Yeah, so all the blood vessels everywhere would be
Oh,
would
right.
be
Okay.
narrowed, trying
Mm,
to decrease or increase the movement of
mm,
blood in that lack of
mm,
fourth phase water state, or that structured water
mm,
on the lining of the blood vessels. So that would happen everywhere. And all this stuff, people, they'll say there's an association between this and heart failure.
mm,
But we know that the heart's job is not to pump blood.
mm,
And so when we talk about heart failure, are we talking about the heart actually failing, or are we
mm,
talking about these other mechanisms in the body increasing the chances of heart failure? Because if we don't have the mechanisms of structured water in the blood, or in the
mm,
arteries moving the blood,
mm,
then the heart is forced to do more pumping because
mm,
the blood is kind of stagnantly or not as forcefully moving into areas, and so the blood is kind of like it's getting kind of
mm.
lagged behind and creating
Yeah.
this more forceful pump, and that's what actually creates this distension. That combined with like poor metabolic health,
Mm,
especially, or poor mitochondrial function in the heart, which are other things that can predispose to heart failure. Or
mm,
you've had some injury to the heart in the past, like you had a heart attack, or I've had people like that tell me like they had damage from chemotherapy to their heart and then developed heart failure. There's damage to those tissues in general. But the way we help heart failure and high blood pressure is building structured water on the
Right.
arteries. And the
Yeah.
research that tells me this is true is the research on infrared sauna
Mm.
and heart failure and infrared sauna on blood pressure. Like it's just phenomenal. Like there's so much
Mm.
research out
Mm.
there that shows that when people use infrared light as a therapy, that
Mm.
blood pressure goes down, heart failure. Sometimes people are completely cured of heart failure
Oh.
when they use it, and it's just tons and tons of
Oh.
research on it. So it's just surprising to me. I mean, it's not that
Mm.
surprising
Mm.
that Western medicine hasn't kind of get into that because the evidence is right there,
Mm.
and it makes sense
Right.
because the sun is our main source of infrared.
Yes.
So yeah, it's
Mm.
all there. That's how you correct blood pressure.
And so, of course, living in the UK, we don't get a lot of sun. So how, what does that mean for us? So is there a particular time of day that is better to go out, even if we've got a day when it's cloudy, or is it just about being out in the daylight?
Yeah, being out in the daylight. So just because
Right,
it's cloudy doesn't mean you're not getting sunlight.
right.
You think about it like there's a reason there's a
Mm,
night and day, even if it's cloudy,
mm,
because the sun is bright and it's coming down. Like it's not as
right.
much when the suns are there blocking it.
Mm,
There's not as much
mm,
UV index and stuff. But still be outside as much as you can.
oh,
And then it
yeah.
makes things like grounding more important.
Mm,
It
yeah,
makes
of
things and
course.
then there are tools you can use like
Mm,
infrared saunas and
yeah.
red light panels and things like this that
Mm,
you can use to boost your red and infrared light exposure.
oh.
But full spectrum sunlight's always going to be best.
Mm,
And so
mm.
doing that as often as you can.
And then being near to nature, being
Mhm.
near to plants or doing a bit of gardening or something, that's also going to help, is it?
Oh yeah, definitely. Just
Right,
being
okay.
exposed to nature and in contact
Mm,
with the earth is huge.
right. Okay. Brilliant. Okay. And so when I go to the gym and there's a sauna in the gym, there's a red light in the sauna. So is that the sort of red light therapy that you're talking about, or is this a different red light?
Hard to say. I don't know exactly what that light is.
Okay.
So
Of course.
it could just be a small like
Yeah.
red LED, which is red
Mm,
light, so that's
okay.
one thing. So red light panels have been shown
Mm,
to do these things, and any wavelength of light will structure the water because all the wavelengths and colors of light that we are native to us
mm,
come from the sun, all the way from UV to infrared,
right.
with all the visible colors of light in between. So all of them will
Right.
structure water. However,
Mm,
when you isolate blue light on its own, like we have in LEDs, they're actually kind of
mm,
damaging to
right.
the skin and to the eyes
Mm,
and to different mechanisms that I would argue aren't so great for structured water.
mm,
But
mm,
then if you look at red infrared light in isolation in therapeutic doses, which
mm,
means and like exposure, but not too much, because there is a threshold by which too much red light would be harmful. Because
mm.
it's all processed light,
Oh,
but there's some that we can use that are beneficial in the short term or for
okay.
small amounts, small doses,
Right.
So,
Yeah.
um, so yeah, so I don't know about that sauna,
No.
but the red light, like a red light LED light, is not the same as infrared. Infrared is non-visible
Right.
light, so you're not going to
Oh,
see it. So it's
okay.
like you have an infrared heater. It's going
Mm,
to create heat, and we actually create
mm,
infrared heat. Like our mitochondria give off infrared heat. So if you put on infrared goggles, people light
mm,
up
mm,
on the
mm.
goggles. So that's the one that's the best to us.
Okay. So because I have seen for sale these like red light panels.
Mhm.
So are they not really of any use?
No, no, yeah, they're very useful.
Oh, right. Okay.
Yeah, it's just there's a threshold. You could do it too
Right.
much and have a negative effect, right?
Oh,
So,
right. Okay.
so you start slow, you
Mm,
start 5 minutes, and I wouldn't do more than like a 40-minute exposure to red light,
right.
maybe, somewhere
Okay.
20 to 40 minute of red
Yeah.
light exposure at a time. I
Okay.
wouldn't do that. There's benefit and then
Mm,
there's a threshold,
yeah.
where it becomes
Yeah.
it can create too many reactive oxygen
Yeah.
species or reactive nitrogen
And
species,
and
things like
so
that.
some of these panels, they do start off quite small. So what do you do when you're using yours? Do you sit facing it, or do you put it on do you put it on your leg, or? your shoulder or?
You could put it on a place where you want the exposure most, like if you're having a
Yeah,
shoulder pain or something like that,
yeah,
like
yeah,
things like, but you could just do full body and you would face it.
yeah.
I probably wouldn't get, like right up next to it like this and look straight into
Okay,
it, just like
okay.
you wouldn't look straight at the sun.
No.
You wouldn't look that close at something that bright. But if you're like a foot or more away from it, yeah, it's okay to be
Yeah.
facing it.
Okay.
That type of stuff.
Okay.
I mean, they're pretty bright, so but they also lots of them will set off. They'll give off red and infrared, like near infrared
Mm,
light as well.
mm,
Which
mm,
near infrared light is especially important. Um, you know,
mm.
for exposure during the day. Again, this is all sun, and you're going to get that even
Yeah.
if it's cloudy going outside. Um,
Outside, yeah,
so
yeah,
yeah.
yeah. Well, we've got dogs, so I'm outside at least twice a day,
Mhm.
walking the dogs. So hopefully, I will be getting enough, um, enough light. So just thinking about sort of beginning to wind this up now, but I want you to talk about why the heart loves ketones and why you don't often see heart cancer.
Mhm. I couldn't tell you exactly why the heart loves Keystone, but we just know that it does.
Yeah.
And so when we look at it, I think it's because it's more metabolically active and it wants a
No.
more efficient fuel source. Again,
Mm,
it's got tons of mitochondria and it's an organ that's constantly moving, constantly contracting. So
mm,
it wants a very efficient fuel source. So
mm,
it seems that even in the presence of glucose, your heart
mm,
cells will preferentially burn fatty acids and ketones, which we know that in most of the rest of the body, like if glucose is present, it will burn that first. So it seems to be
mm,
different for the heart.
mm,
And that's one reason I think that heart cancer is so rare, because
mm,
it is, or very rare. It does happen, but it
mm,
is very rare. And most of the time when it does happen, it's because heart or cancer happens somewhere else and it metastasized to the heart.
mm,
That's much more likely for that to happen than for cancer to be the primary location of, like, for cancer to start. But
mm,
that does happen too, but it's just very rare. And despite rising cancer rates, heart
mm,
cancer continues to be very, very rare.
mm, mm,
And I think one of the reasons is that it's preference for ketones because, cancer, it's very clear that a cancer cell is something that goes from, being metabolically healthy to going into fermentation, which
yeah,
it can only do like using lactate or glucose,
mm, mm,
and so ketones are a fuel source that cannot be fermented. And so it kind of
right.
keeps it from
Yeah.
that,
Yes. So
keeps it
that
from
with
doing
that,
that.
because I've listened to a few podcasts with Dr. Thomas Seyfried, and he talks about, cells that are going cancerous go into that fermentation
Yeah, the question is
process.
why
Yeah.
though?
Mm,
Why are they going more toward the fermentation?
mm,
And the reason is that, well, they'll say that the reason is that we have poor metabolic health, which I agree with.
mm, mm,
But the question is, why do we have poor metabolic health? And it's
mm,
not just
mm.
because of our processed food diets; it's because of
Okay.
our changing light environment as well. Because
Right.
our circadian rhythm is off,
Mm,
because we're deficient in sun exposure, those types of things.
mm, mm,
That's why.
mm. Yeah.
Um, so yeah.
Yeah. So just before I ask you to talk about your new book, because I do want to know about your new book. So I just want to kind of bring all of this together really. And so basically, if we want to be healthy and if we want to keep our heart healthy, we are better off eating an animal-based diet, keeping our carbohydrates low, following a low-carb lifestyle, um, eating animal fats, would you
Yeah.
say?
Mhm.
Animal fats are better. Getting plenty of sunlight, getting out into nature, doing a bit of gardening or just walking in the park, something like that.
Yeah.
And also, what else? Oh, yes, and also limiting our blue light. So, is that basically so as we're getting towards the evening time, put our phones away, not go on the computer or something?
Yeah. So I mean, processed blue light, no matter, regardless of time of day, is going to be
Right.
harmful to us. It's going to
Ah,
be damaging to the photoreceptors in our eyes and our skin.
okay.
It creates an imbalance that I think is what's driving skin cancer. It's not the sun at all. And
That's
so,
interesting.
yeah. And there's evidence that modern windows and artificial light are the real drivers of the
Uh,
imbalances that eventually lead to skin cancer,
oh, right.
and not sunlight. So it's bad for you regardless of time of day. But it's for optimizing circadian rhythm, it's most important to block that blue light, especially after the sun
Mm,
is set. So that
right.
means limiting screens. Any indoor lighting is going to be blue light.
Mm,
So blue blocking glasses, things like that.
right.
Um, Very useful for
Mm,
mitigating
mm,
the
mm.
disrupted circadian rhythm from artificial light.
Okay, brilliant. And so, would you tell us about your new book? You've got a new book out called, is it Pain Sense?
Yeah.
Yes.
So I kind
What's
of
that
tackled
about?
this epidemic of chronic pain that we're having.
Mm.
People may or may not know, like the whole opioid crisis happening in the United States because of
Mm,
a certain pharmaceutical industry and overuse of opioids.
mm,
And so, yeah, I kind of approached chronic pain um, from a more holistic or natural point of view, and how, like,
mm,
explaining what pain is, because there's different types of pain. There's
mm,
sensory pain, there's emotional component to pain, and there's a cognitive
mm,
aspect to pain, which the cognitive
mm.
aspect is unique to humans. And
Oh.
so, analyzing it in that sense, and then understanding these mechanisms of body charge and coherence,
Mm, mm,
and body communication systems and blood flow, or I guess fluid flow in the body, not just blood. um, but explaining why we have pain from that perspective, because
right.
that gets to the root problem, rather than just saying, okay, here's this pain medication that blocks pain, or
Mm,
blocks the sensory pain. But what if it's not just
mm,
sensory pain? What if it's cognitive pain? Then that's not going to do
mm,
much. The only way that it's going to affect or be successful is if it's such a high dose that it
yeah,
basically knocks you out and you don't have any
mm,
cognition whatsoever.
yeah,
That it works that way, but that becomes very addictive.
yeah,
So,
sure.
yeah, so lots of things to talk about when it comes to pain,
Okay,
and
brilliant.
trying to figure out the best way to approach that.
And when is that book out?
Hopefully within the next month or so.
Oh,
Um,
okay.
yeah,
That's good.
so
So when
yeah,
that comes out, maybe you'd like to come back and talk to me about that book.
sure,
Go into
yeah,
a little bit more detail about it. So
for sure.
I'd really love that. So where can people find out more about you and the work that you do?
Yeah, my website is resourceyourhealth.com.
Hmm.
And people can contact me through there. My recommended products are on there. My blog is on there. My health consulting is on there. And then I'm on social media. Just Dr. Stephen Hussey, Dr. Stephen Hussey is the handle for those.
Hmm.
And then my books are on Amazon. The new one hopefully is out soon. But yeah, that's people can find me.
Brilliant, brilliant. Well, thank you so much, Dr. Hussey, for talking to me today. It's been really lovely and so enlightening after having read your book and then talking to you about it. It's been really, really lovely. Thank you so much. And hopefully I'll speak to you again when your next book comes out.
Of course, I'd love to. Thanks for having
Yes.
me on.
Okay. Well, take care and speak to you again soon. Thanks
Mhm.
so much. Bye now.